Come in, it's open.
Good afternoon, boys. How was it at school today?
Okay, grand.
Usual stuff, madam.
That's good to hear. Would you like some juice?
Yes, please, yeah. Would you like to have it with a straw? Just
Thank you, Miguel, but I've got my own juice in my school bag, if you don't mind.
Not at all. Watch out, Justin. Atmospheric pressure is crushing your juice carton.
And watch out, Miguel, atmospheric pressure won't help you drink if your lips don't create a tight seal around the straw.
The process starts when the person sucks from the straw while creating an airtight seal around it. In doing so, the pressure inside the mouth and the pressure of the air at the top of the straw is reduced. This is because air previously present in the straw and mouth is shifted into the lungs, leaving an area of low pressure into the mouth. When this happens, the atmospheric pressure acting on the surface of the liquid is now greater than the air pressure inside the mouth. As a result, the liquid is pushed up the straw into the mouth, enabling the person to drink.
Boys, would you mind handing me over those clean white bottles by the sink? Thank you.
I know this method. We learned it at school. It is called the siphon effect, Mr. Burch.
A rubber tube can be used to remove liquid from a container at a higher level to another at a lower level.
The tube has to be filled with a liquid. The tube has to be filled with the liquid. Then one end needs to be placed in the liquid in a container. The other end is then placed at a level which must be lower than the surface of the liquid in the first container.
The pressure in the rubber tube at the lower end is equal to the atmospheric pressure plus the pressure due to the column of the liquid.
As the pressure at the lower end is greater than the atmospheric pressure, the liquid flows out. This is called the siphon effect.
I think I can explain that using physics.
I think I know where you are heading, Justin.
Imagine a group of students representing air molecules at a high temperature.
Imagine a group of air molecules which get trapped under the lid. These trapped molecules gain thermal energy and start moving at a higher speed. Therefore, the pressure under the lid increases. The pressure outside, that is the atmospheric pressure, does not change. As the pressure under the lid becomes bigger than the atmospheric pressure, some molecules from under the lid manage to escape, leaving a smaller number of molecules under the lid. After some time, these molecules lose their energy, since the lid cools down and the pressure under the lid decreases, such that it is now smaller than the atmospheric pressure acting on the outside of the lid. This difference in the pressure caused the lid to be forced down against the kitchen top. Oh my, what an interesting explanation, boys. I guess you truly deserve a reward. How about a slice of lemon meringue pie?
I'm afraid I still have to finish the pie, but if you help me, we'll be ready in no time.
Do you by any chance have a small empty plastic bottle?
I've got one. What are you up to, Miguel? I got this.
What happens here is that when the bottle is squeezed, there is a lower pressure inside it than the atmospheric pressure outside. So when you put the bottle opening over the cork, atmospheric pressure pushes the cork inside the bottle.
It's a pity your friend had to leave.
Well, more for us.